Okay, let's pick up now with page 2. We're going to jump to question 7-73. And it says, for each diagram below, find the value of x if possible. If the triangles are congruent, state which triangle congruence condition was used. If the triangles are not congruent, or if there's not enough information, state cannot be determined. All right, so let's take a look at this first one. We've got a triangle down here with a pair of congruent sides marked here, and the triangle on the left and on the right. I'm going to add a point right here. I'm going to call that point D. And I also see that I've got this side that is in both triangles. And I see that I've got, I'm going to have another right angle here on the left-hand side of that segment that's segment BD. Okay, so right off the bat here, I'm going to say that triangle ABD is congruent to triangle CBD by side angle side congruence. Okay, and now here's where the title of the lesson comes into play. Notice the title of our lesson was More Proofs with Congruent Triangles. So on the back side of this notes page, that's where we're going to be working with congruent triangles. Now I'm asked to find here the segment length of DC, which is labeled as X. But I first want to highlight this triangle right here. Triangle on the left, and that triangle is triangle ABD. It's got a hypotenuse whose length is 10, and it's got this leg here whose length is 8. I actually know that the other side here is 6. So that length AD is 6. And the reason why is because that's a Pythagorean triple. If you recall, we had the 3, 4, 5 right triangle, which we worked with in the past. And this is just a multiple of that. You double the 3, 4, 5, and you get the 6, 8, 10. Okay, so now I'd like to make a claim here. We're asked to find this length X, and that's side DC. Well, I'd like to make the claim that AD equals DC. So if AD equals DC, and I know that because it was marked in the picture, that means that X equals 6 units. Okay, and that congruent mark was shown in the picture there. But I also want to bring another thing to your attention. If we have two congruent triangles, their corresponding parts are also congruent. So sometimes you'll see this written as follows. You'll see congruent triangles have congruent parts. Another way you'll see that written, and this one, folks, is really kind of strange. You'll see it written as follows. CP, CT, C. And I'm showing this to you. I don't use this often. Our textbook doesn't use this that often, but you will see it occasionally, especially in traditional triangle congruence proofs. So I just want to tell you what the heck those letters mean. So we got this CP, CT, C, and it actually means the same exact thing. This acronym means the same exact thing as this, and it stands for the following. Corresponding parts of congruent triangles are congruent. So again, it means the same thing as congruent triangles have congruent parts. Just to let you know, you might see that. Let's move on now to part B. We've got a set of triangles here. Let's look at the given information. Given information we have is that this segment is parallel to this segment. Notice that does not mean that they're the same length. We might be able to prove that they're the same length, but that information is not given to us. Okay, we also know that we have a pair of angles that are the same. Those two marks there mean that those two angles are congruent. And did you notice a shared side? We've got side length BD here, which is between both the triangle on the left and the triangle on the right. So that's a shared side there. I also have, because of that parallelism, we have a pair of alternate interior angles. There's the Z shape for you. And from that we can add that angle ABD is congruent to angle CDB, okay, because alternate interior angles are congruent. So I'm going to go ahead and write out a congruent statement for those two triangles right now. It'll look something like this. And the tool we would use there would be angle side angle. Now let's go back and see if we can find out what this value of x is. Well, we know this. We were given in the original figure that AD was equal to 10 units. And I know that AD is going to be equal to CB. And the reason for that, that's the thing we just talked about. Congruent triangles have congruent corresponding parts. So that means x is 10. All right, we're cooking through this, folks. Let's now go on to part C. Part C looks like we start with a rectangle. They've drawn in a diagonal and told us that we've got an angle here of 35 degrees. Automatically, I'm going to start looking at this, and I know that the opposite sides in a rectangle are parallel. We just proved that in the front side of the notes. So I've got the Z shape there. That means that this angle here is also 35 degrees. And let's go ahead and kind of collect our information here. ABCD is a rectangle based on the definition of a rectangle. I know a rectangle is a parallelogram. How do I know that? Well, that's one of the features of rectangle. We proved it on the front side of the notes. I also know that the measure of angle DCA is going to be equal to 35 degrees, and that's the thing we just talked about. Alternate interior angles between parallel lines are congruent. So now let's see if we can find x. Well, what do we got to do now? We're done with our work on congruent triangles. Now we're looking at a triangle here. I got a right angle. Right angle. I know that this angle here is 35 degrees. I know the opposite leg is 11. Let's go ahead and label that as such. That's the opposite leg. That would make this the adjacent leg. Oh, it looks like we're jumping back into right triangle trig here. I think we're going to say this. The tangent of 35 degrees is equal to the ratio of 11 to x. And that means that x will equal 11 divided by the tangent of 35. And that gives you a value for x. Hold on, folks. That gives you a value for x of about 15.7 units. Okay, one last problem here. Let's look at part D. We got side segment AC and BD are straight line segments. And that means that we can go ahead and start adding some information in this picture. So we've initially, the first thing I look is I've got a pair of vertical angles. I know that's one of the first things we jump to in these pictures. I don't even really need that because I also knew that I had a pair of congruent angles here. And then I've got this 47-degree angle here and here. So we have two triangles where all three angles are congruent. So I know this. I can say that triangle AB, oh, let's go ahead and name this point right here E. ABE is similar to triangle CDE by angle-angle. But here's a problem. Angle-angle does not guarantee congruence. It only guarantees similarity. So we have this issue here right now where we cannot, and I repeat, we cannot prove that the triangles are congruent. So we cannot find x. And that's it, folks. That's all we've got for the notes here in section 7.2.3. Please dive into the review preview problems and let me know if you have any questions. Thank you.